So the last piece of the spectrophotometer for FTIR that we need to talk about is sample holder. And so some IRs will use a gas sample holder if you're going to do a gas, but a very common one to do liquid or solid analysis is to use an ATR, an attenuated total reflectance. Attenuated total reflectance sample holder, okay? And so in this video, we're going to talk about what is the ATR and how does this work. This is actually the sample holder that we have on both of our FTIR instruments in the lab that you should be using as part of your lab experience for this course. And so how does this work exactly? Okay, so in this case, what we have here is we have a crystal that has a really high refractive index. And if you think back to physics, you might think about Snell's law and how when light goes from one medium to another medium with differing refractive indices, you get a change in angle with which the light is moving. So it changes in angle based on the refractive index. Okay. This is especially true when you're going from a more dense medium, such as in this crystal, to a lower dense medium, such as air. Okay? And when I say a high refractive index, I mean to say that this is quite high. It's anywhere from a refractive index, which we denote by an N, of 2.4 to 4. Okay? By comparison, glass is only about a 1.6 or 1.7. Water is a 1.0. Okay, so we're quite high compared to even normal everyday materials. Okay, so when our light from our interferometer comes in, I might change colors here just so you can see this a little bit more distinctly. Okay, so what happens as it passes into our crystal is that the angle is going to change slightly. Okay, now when we reach the end of the crystal, normally we would think that this is going to pass completely out, but because of the great difference between the density or the refractive index of the crystal and its surroundings, as this light passes up, the angle actually is such that while it penetrates slightly into whatever is above it, it's actually going to be completely reflected back. Okay, so what we get is complete reflection here. So this difference in refractive index causes reflection to occur when we would normally think the light's going to be transmitted through it. But this difference actually causes complete reflection. And the angle that this occurs at is called the critical angle. So we get complete reflection at the critical angle. Now, the research and experiments actually show that this light actually penetrates the medium above it that has the lower refractive index point at this reflection point. So we get a little bit of penetration where the light is actually penetrating into whatever sample we might have put on top. And so as this has then reflected back, we get again internal total reflection down here, and it can come back up and penetrate again, and so on and so forth across the sample till it ends up heading to our detector. Okay. So it's going to enter the sample several times across this crystal, and each time it penetrates, it interacts with the sample. And as we've talked about, as light interacts with the sample, at the point of interaction, we get absorption. And so this is how an attenuated total reflection setup can actually get us to see what kind of light absorption an otherwise opaque sample would have, because we don't need the light to transmit completely through it. We simply have slight penetration into the substance as it's being internally reflected. So why do we want to use this? Some of the huge advantages are that the absorbances are independent of sample thickness. Because this penetration is only a few micrometers thick, this penetration is so thin that we can do thin films of samples, and you can do this with a very small amount of sample. You'll notice when you use our FTIRs that the crystal itself is not very large, and it doesn't take much sample to be able to cover it completely and get a good spectrum of your sample. Also, an advantage is that there's really no sample prep required. You don't have to dissolve it in a liquid, you don't have to do some kind of vaporizing your sample in order to see it. It literally is just set your solid sample on your platform and you're good to go. Finally, we can use this on lots of sample types. In the examples I've talked about here, we're talking about solids particularly, but you can also put liquids directly on the crystal and obtain their FTIR as well. So we're not limited to a specific sample type using ATR. Alright, so that's a little bit about our ATR sample holder, and that's the last piece of the instrumentation puzzle that we needed to complete FTIR.